Hi everyone, we're picking up with section 18 in our class, and our first prep skill is going to be working with inequality notation. So inequalities they're similar to an equation or to an equal sign, but they are for when you want a particular set of numbers that are greater than, less than, in between two numbers, or you could also have less than or equal, greater than or equal. So for instance, if we want the set of all numbers that are less than or equal to -5, we would write x less than or equal to -5. Now, sometimes people have a hard time reading the symbol. If you remember that the arrow always points towards the smaller thing, or it opens like a mouth towards the bigger thing, and if I look at this and I know this is bigger and I want to read it from left to right, I know that x must be smaller. So x is less than or equal to -5. So as you read it, you know, well, this is the larger thing because the mouth opens that way. So x is less than or equal to -5. If you want to be between, so this means that you can be -5 or smaller. So you can be -5, -5.1, -5.2, -6, -20, -100, and just keep going down from there. The set of numbers that are between two numbers we write like this. So this would mean x would have to be between 6 and 12, but it couldn't include 6 or 12 because we don't have the equals. If we put an equals here, that means you could include the 6, like you would actually start at the 6, but then you'd have to go up to and stay under 12. That doesn't mean you stop at 11. You could have 11.9999999. It just can't get actually to 12. And that's called a compound inequality. And when we do these, we always put the smaller number on the left and the larger number on the right. So you wouldn't want to say 12 is greater than x is greater than 6. That doesn't make sense. We always want to read it left to right from the smallest to biggest number. So we tend not to do that. The expression t is greater than or equal to 8 means we're going to start at 8, and then we want the set of numbers that are equal to 8 or bigger. This would mean y less than 4 means we want to stay less than 4, which means we could go all the way up to 3.9 whatever, as long as we didn't get up to actually 4. And then this is kind of like I was talking about here. This one originally, if we remember, didn't have an equal sign here. -3 is less than or equal to x is less than 2. This means we could include the -3 on the left side, but we can't include the 2 on the right side. So this would actually start at -3 and include all the numbers up to, but not including 2. So now just a quick summary of the symbols. This symbol would mean greater than, because if we put something on the left, say we put a 5 here, and that was greater than 2, then the thing on the left is going to be bigger because it opens that way. And so since the thing on the left is bigger, then 5 is greater than 2. Less than, if we put the smaller number on the left, so say -1 is smaller than 8. So -1 is less than 8. Then if we do the symbols with the equal sign underneath, greater than or equal to, less than or equal to, it just means that you can actually include that number. So right here then, one of the other skills that we need for this lesson is being able to simplify algebraic expressions. So we're going to start with an expression such as 2 times x plus 4 minus 5x. Now this isn't an equation because I don't have it equal to anything. It's like one side of an equation. So I want to simplify this so that it looks a little bit nicer. So I could distribute. In this case, that would be 2x plus 8 minus 5x. And then we're going to combine the like terms. So we have -3x plus 8. On the next one, 4y plus 10 minus 3y plus 5 in parentheses. This negative is going to act like a -1. Let me rewrite that. So we could think of it as 4y plus 10 minus 1 times 3y plus 5. And we could even think of it as like plus a negative 1. But this negative is going to get distributed. So I'm going to have 4y plus 10 minus 3y and minus 5, because negative 1 times 5 would be minus 5. So if I do 4y minus 3y, that just gets me y. Combine that term with that term. And then we're going to combine the negative 10 with the negative 5 to get negative 15. I've done something wrong because I have a different answer than they do. Oh, I've changed this sign right here by accident. That was supposed to be a plus 10. So it's not minus 15, it's actually a positive 10 minus 5 would give us a positive 5. So on this slide we have our first two parts to our prep skills questions. And the first one here says we're supposed to write an equality to represent. So all real numbers that are at least 17. So that means you could have x to be greater than or equal to 17. Bigger than or equal to, because it says at least. So it doesn't say greater than, it says at least 17. So that includes the 17. Numbers between negative 5 and 5 along with 5. So we want to include the 5, but we don't want to include the negative 5. So we're going to start at negative 5. We're going to put the x literally between them. And we're going from negative 5 to 5, but it says include the 5, so less than or equal to 5. It doesn't say we want to include the negative 5 though, so we'll leave it like that. A group of test scores that are no more than 90. So 90 is the largest. No more than 90. So the test scores are less than or equal to 90. Positive numbers that have a maximum of 32. So it would be all the numbers that are less than or equal to 32. And then the variable quantity represented by y is at most 3/2. So y has to be less than or equal to 3/2. They did a lot of equals on this one rather than mixing it up. But on this it says write a verbal description. I'm not going to write these all out. I'll just say it. So this is all the t's, I guess I could say it out, that are greater or equal to, oh, I said that backwards, less than or equal to, to 3. So, or we could say the set of numbers that are no more than 3. There's different ways to say these. X is greater than negative 10 means we want all the set of numbers, all the x's that are larger than 10. Sorry, negative 10. There's a negative on there. All right, in here we literally want P to be between 300 and 500, not including either end. We want them strictly between. So we, you could, as long as it was a little bit above 300, so even like 300.1 if that was possible in the situation. So 300.1 would be bigger than 300. In fact, 300.0001 would be bigger than 300. So as long as you're just barely bigger than 300 and you don't quite reach 500, you're going to fit in that category. And then last but not least on this page, we have 0 is less than or equal to k is less than or equal to 9. And in this case, k is between 0 and 9, including both. So if you're 0 or if you're 9, you would still be in that group. Whereas if we left the equal signs off the bottom here, you couldn't put 0 or 9 in the group because they aren't between k, they're and 0 and 9. They're actually at that location. So for this next part, we have two parts here. Simplify each expression as much as possible, and then find all the solutions to each equation. So for this first one, remember we're just simplifying, not solving. We're not going to end up with an x equals. There's no equation, no equal sign here. So I'm just going to distribute. I get 8t minus 44 when I distribute the 4 through. And then plus 3t. Adding the 8t and the 3t gives us 11t. And then we have the minus 44. Here I've got 8y plus 4 minus 4 times 7 minus 3y. I'm going to distribute this negative 4, and this is a negative 4 because it's got the minus in front of it. So in other words, we could rewrite it if we wanted to as plus a negative 4, and then the negative 4 would get distributed. But most people don't bother with that. They can recognize that there and just leave it. And so we've got, let me change my color back. So we've got 8y plus 4 minus 28 plus 12y. So I'm going to put the 8y and the 12y together and get 20y. And then I'm going to put the plus 4 and the negative 20 together and get negative 16. On this one, we've got two sets of parentheses, so we have to get rid of both of those first. So distributing through the first one, we have 10x plus 5. And then distributing this negative through the second set of parentheses gives us minus 5x minus 3. Then at the end we have a plus 2x and a plus 10 that are just kind of hanging off there on the end. So then if I take my 10x with my minus 5x with my 2x, that actually gets me 7x. And then 5 minus 3 is 2. So we're going to put this plus 5 with this negative 3 with this 10. That would give us plus 12. And then on these, we're going to solve the equation. So I'm going to go down just a little bit here. Let's go x plus 2 equals 5. So if I subtract 2 from both sides in this case, I get x equals 3. And if I plug that back in, I'm saying 3 plus 2 is 5, which we know, of course, is true. So to check it, if you want to do a quick check, make sure at the end that your answer fits into the equation that you started with. Okay, so for this next one, I have y minus 3 equals negative 10. To undo a minus 3, I'm going to add 3. And so y equals negative 7. If you want to make sure it works, take it and plug it back in. Does negative 7 minus 3 equal negative 10? And yes, it does. 5x equals 35. Oops, I don't know why I put the 35 underneath there. So 5x equals 35. And since this is only one thing that's keeping the x from being alone, from being isolated, is this 5, it's a multiplication, so we're going to divide. So x equals 7. And if you put that back in there, 5 times 7 is 35. The last one is has got some bigger numbers in it. It's got division, but it's still only one step to solve. So if we had p over 365 equals 10,000, then to get rid of this 365, I'm going to multiply by 365. So I've got p equals 365 so 3,650,000 is what p ends up being. So at this point, we're going to go to the other videos and go to the class and the group work and the applications.
Here we're looking at what happens when you have an inequality and you do arithmetic operations to it. So in question 1, we have 10 is less than 20, and we're asked to add 8 to both sides. So if I do 10 plus 8, I get 18. And 20 plus 8 is 28. And then comparing those, 18 is less than 28. So adding something to both sides does not change the direction of the inequality. In number 2, what if we add a negative? Does that make any difference? So we'll add negative 8 to both sides. 10 plus negative 8 is 2. 20 plus negative 8 is 12. And 2 is still less than 12. So we're okay there. In 3, what about subtraction? If we subtract 6 from both sides, 10 minus 6 is 4. 20 minus 6 is 14, and 4 is still less than 14. What if we subtract negative 6 from both sides? Well, what we have to be careful of is that subtracting negative 6 is the same as adding 6. So 10 minus negative 6 is 16, and 20 minus negative 6 is 26. Well, 16 is still less than 26. So we can add or subtract either positive or negative numbers to both sides, and the direction of the inequality will remain the same. In 5, we're summarizing what we've been learning in the last few problems about adding and subtracting numbers to both sides of an inequality. And what we decided was that that does not change the direction of the inequality symbol. So then we're going to solve two inequalities as examples. In the first one, x minus 5 greater than 9, we need to start by adding 5 to both sides. That's going to leave us with an x on the left greater than 14, and I can leave that as a greater than because it does not change the direction of the inequality. Now, to graph that answer on a number line, we're going to start with a 14, and you can pick anywhere on there that you want your 14 to be. But to show that the 14 is not included, I'm going to use an open circle at the 14. Now from there, it's greater than 14, so I want all of the values to the right. So I'll draw an arrow from there out to the right. To check that, I just need to pick something greater than 14 to plug in. So let's maybe try x equals 15. Well, if I plug 15 in, 15 minus 5, is that greater than 9? That gives me 10 greater than 9, which is indeed true. For the second one, I have t plus 11 less than or equal to 5. To get the t by itself, I need to subtract 11 from both sides. I'm allowed to do that as well. So I get t less than or equal, because that does not change direction, negative 6. To graph that on the number line, I'm going to label a negative 6 somewhere, but this time it's less than or equal, so the negative 6 is included. To show that, I'm going to fill in the circle at the negative 6. And then to show that it's less than that, I can put an arrow off to the left. To check that, I need something less than negative 6, so maybe negative 10. I can plug that in, negative 10 plus 11. Is that less than or equal to 5? Well, that gives me 1, which is indeed less than or equal to 5. So that checks. Now in 6, we're supposed to write a verbal description of what each of those mean. They've given us an example for the first one. And what they're saying is that since we found that x was greater than 14, that means that any value of x greater than 14 will make x minus 5 be greater than 9. So similarly, for the second one, we have t less than or equal to negative 6. That means that any value of t that is less than or equal to negative 6 will make t plus 11 be less than or equal to 5. We've got another set of inequalities where we're going to perform operations to both sides and see what happens. So in number 7, we have 10 less than 20, and we're asked to multiply both sides by 2. So if we do that, on the left, 10 times 2 is 20. And on the right, 20 times 2 is 40. And 20 is less than 40. So that has not changed the direction of the inequality. In 8, we're going to multiply both sides by negative 2. So 10 times negative 2 is negative 20. And 20 times negative 2 is negative 40. And here you need to be careful, because with negative numbers things can feel backwards. Negative 20 is actually a larger number than negative 40 because it's farther to the right on the number line. Or if you want to think about being in debt, if your bank account is at negative 20, that's better than having your bank account at negative 40. So this actually changes the inequality symbol to a greater than. In 9, we're going to divide both sides by 5. So 10 divided by 5 is 2, and 20 divided by 5 is 4, and 2 is less than 4, so that one does not change the direction. But in 10, when we divide both sides by negative 5, 10 divided by negative 5 is negative 2, And 20 divided by negative 5 is negative 4. And similar to what we just talked about, negative 2 is actually a larger number than negative 4. So that one changes to a greater than. So it looks like multiplying and dividing by a positive number doesn't change the inequality, but multiplying or dividing by a negative number does. Here we're going to summarize what we've just been looking at with multiplication and division. So if you multiply or divide both sides of an inequality by a positive number, the direction of the inequality or comparison symbol stays the same. But if you multiply or divide both sides by a negative number, the direction of the inequality symbol changes. So let's try a few examples. First we have 2x less than 10. Well, to get that x by itself, we need to divide both sides by 2. And so that gives us x less than 5. And when we graph that on a number line, we're going to have an open circle at 5 because it's not less than or equal, so the 5 is not included. And then for less than, we're going to draw an arrow from there to the left. To check that, we need to pick something less than 5 to plug in, so maybe 0. And if we plug that in, we get 2 times 0 less than 10. So that says that 0 is less than 10, which is true. Our next inequality is negative 3z greater than or equal to 12. So here we need to divide both sides by negative 3. And what we've learned is that that will actually change the direction of the inequality. So we're going to end up with z less than or equal to negative 4. So then graphing that on the number line, because it's a less than or equal, the negative 4 is included. So I will put a filled in circle at the negative 4, and then for the less than part we will again draw an arrow to the left. Plugging something in to check that, we need something smaller than negative 4, maybe negative 10. And so plugging that in, negative 3 times negative 10, is that greater than or equal to 12? Well, on the left that gives me 30, and 30 is greater than or equal to 12, so that is true. The next one is 1/4 t greater than negative 3. Working with fractions, we need to multiply by reciprocals. So if I have 1/4 t, I need to multiply both sides by 4 over 1. And so that's going to give me t greater than negative 12. Graphing that on the number line, the negative 12 is not included in this case, so I'll have an open circle at negative 12, and for a greater than, my arrow will point to the right. To check that, I need anything bigger than negative 12, so maybe 0. And so I'll plug that in. 1/4 times 0, is that greater than negative 3? Well, that's 0 greater than negative 3, and that is true. Our final one is negative 1/3 b less than or equal to 2. So we're still going to multiply by a reciprocal. This time, that reciprocal will be negative. We're going to multiply both sides by negative 3 over 1. And multiplying both sides by a negative number is going to change the direction of that inequality. So we're going to end up with b greater than or equal to negative 6. To graph that on the number line, the equal option means that the negative 6 is included, so I'll fill the circle in, and then greater than means the arrow will point to the right. We can check that with anything we want. 0 works well again, so b equals 0 because that is greater than negative 6. I'll plug that in. Negative 1/3 times 0, is that less than or equal to 2? That gives me 0 less than or equal to 2, which is true. We're going back to this formula from our snow cone business that profit equals negative 245 plus 0.63x, where x is the number of snow cones sold. And in question 1, we're asked to write an inequality that states in symbols that the profit for this business will be at least $100. Well, first of all, the profit formula has negative 245 plus 0.63x as equaling the profit. So we can go ahead and start with that, and then we want that value to be at least 100. At least means greater than or equal, so we'll say greater than or equal to 100. And then in 2, we're supposed to go ahead and solve this. So let me start by recopying it. And then we start trying to get x by itself. So first I need to add 245 to both sides. And I can do that without changing the direction of the inequality. So now I have 0.63 times x greater than or equal to 345. Now I need to go ahead and divide both sides by 0.63. And since I'm dividing by a positive number, that also does not change the direction of the inequality. So I end up with x greater than or equal to approximately 547.6. And then in 3, we're going to graph that solution on the number line. Well, for that means that the x values start at 547.6, and because it's greater than or equal, I'm going to go ahead and fill that in with a solid dot. And from there, with a greater than or equal, you're going to the right for the values that are larger. In 4, show that one value from the solution set checks. Well, that means you can pick anything larger than 547.6, so maybe 600. If we plug that back into the original inequality, negative 245 plus 0.63 times x, we'll put 600 in there for x, is that greater than or equal to 100? Well, negative 245 plus 0.63 times 600 comes out to 133, and so yes, that is greater than 100. So it makes the statement that it's greater than or equal to 100 true. In 5, what does this solution tell us about the company? Well, they need to sell greater than or equal to 547.6 snow cones to make a profit of at least $100. They can't sell 0.6 snow cones, so that means they're really going to need to get over 547, which means 548 or more, to get that profit. So in 6, write a verbal description of what this inequality represents. Negative 245 plus 0.63x less than 0. Well, that left-hand side is our profit. And so this is saying that this is where the profit is less than 0, or where the business is losing money. So then in 7, we're going to solve that inequality. First, let me recopy it. So then the first step to solving that is to add 245 to both sides. And that's going to give me 0.63x less than 245. Then I need to divide both sides by 0.63. And so that gives us x less than approximately 388.9. And then in 8, graphing that on the number line, we need an open circle at 388.9 because it is not included. And then to graph x less than that, we'll draw an arrow from there to the left. In 9, show that one value from the solution set checks. So we need something less than 388.9. So maybe 300. And we'll plug that in. So negative 245 plus 0.63 times 300, and is that less than 0? So that comes out to negative 56 less than 0, and that's true. And then in 10, what exactly does this solution tell us about the business? Well, it tells us that it's going to lose money or have a profit less than 0 if they sell less than 388.9 snow cones. So that would be really, since there's only whole snow cones, less than 389, or you could say 388 or less. So we have a computer server room, and we're told that server rooms should not dip below 50 degrees Fahrenheit and should not exceed 82 degrees Fahrenheit. So in 11, they want us to write an inequality focusing on that first part, that server room temperatures should not dip below 50 degrees Fahrenheit. So that would be that F can't go below, which means it could be greater than or equal to 50. In 12, earlier in the course, we learned conversions between Fahrenheit and Celsius. And so we have this conversion. If you know the temperature in Celsius, you can convert it to Fahrenheit. Use this to turn your inequality from question 11 into one with a variable c. So what they mean is take that formula and plug it in for the f. So now you have 9/5 c plus 32 greater than or equal to 50. In 13, let's solve that inequality. So the first thing we'll need to do is subtract 32 from both sides. That's going to give me 9/5 c greater than or equal to 18. Now I need to get rid of that 9/5. I've got 9/5 times c. I need to multiply both sides by the reciprocal. So I'm going to multiply both sides by 5/9. And so that's going to give me c greater than or equal to 10. And so what does that tell us? Well, we already knew that in Fahrenheit the temperatures needed to be greater than or equal to 50. Now we know that in Celsius the temperatures need to be greater than or equal to 10 degrees. We're still talking about the temperatures for the server room, and in 14 we're going to look at the second half of that requirement, write an inequality to express the statement that the temperature should not exceed 82 degrees Fahrenheit. So F should not exceed, which means it can't go over, but it can be less than or equal to 82. In 15, we're going to use our conversion formula. We know that F equals 9/5 c plus 32. So we can plug 9/5 c plus 32 in for the F. That's going to give us 9/5 c plus 32 less than or equal to 82. In 16, we're going to solve that. So the first thing we'll do is subtract 32 from both sides. And that gives me 9/5 c less than or equal to 50. Now I need to get rid of that 9/5 c. I'm going to multiply both sides by the reciprocal. So I'll multiply both sides by 5/9. And that's going to give me c less than or equal to, it would be 250 over 9, but when we're talking about temperatures, decimals make more sense. So that would be c less than or equal to 27.8. And what does that tell us? Well, that tells us that that server room should be less than or equal to 27.8 degrees Celsius. We're still talking about the temperatures in the server room, and 17 actually asks us to put together our answers from questions 13 and 16. So in question 13, we learned that C needed to be greater than or equal to 10. And then in 16, we learned that C needed to be less than or equal to 27.8. So what that was really saying when you put them together is that this server room needs to be kept between 10 degrees and 27.8 degrees Celsius. So to write that as a single compound inequality, we'll say that 10 is less than or equal to C, which is less than or equal to 27.8. In 18, it asks us to write a single compound inequality to describe that temperature in Fahrenheit. Well, remember that in Fahrenheit, we had that the Fahrenheit temperature needed to be kept greater than or equal to 50, and it also needed to be kept less than or equal to 82. So putting those together in a single compound inequality, we'd have 50 less than or equal to F less than or equal to 82. So then in 19, we're going to use our conversion formula to convert that to an inequality in terms of C. So remember we had that F equals 9/5 C plus 32. We'll plug that in for the F in number 18. So we'll have 50 less than or equal to 9/5 C plus 32 less than or equal to 82. And then we're asked to solve that. Well, now instead of 2 sides, we need to do everything to 3 different parts. So first I need to subtract 32, and I'm going to subtract that from all 3 portions of that compound inequality. That's going to give me 18 less than or equal to 9/5 c less than or equal to 50. And then to get that c by itself, I'm going to need to multiply by 5/9. So I'll multiply all 3 portions by 5/9. And that's going to come out to 10 less than or equal to c less than or equal to 27.8. And they asked, does that match what happened in number 17? And yes, that does match the answer that we had there. We're looking back at a formula we had from lesson 3.1 for cab ride costs. C equals 5.1 plus 2.6 times m. And in question 1, what is the inequality 5.1 plus 2.6 m less than or equal to 20 represent in this scenario? Well, since the left-hand side is the cost of the cab ride, this is saying that the cost of the cab ride is less than or equal to $20. And then 2 asks us to solve that. So we'll do that over here on the side. So to get that m by itself, first we'll need to subtract 5.1 from both sides. That's going to give me 2.6m less than or equal to 14.9. Now I'll divide both sides by 2.6. And that'll give me m less than or equal to approximately 5.7. To graph that on the number line, the less than or equal means that the 5.7 is included. So we'll have a filled in circle at 5.7, and then for less than, the arrow from there will go to the left. In 3, write a sentence describing what that tells us. Well, that tells us to keep this cab ride at $20 or less, we'll need to travel 5.7 miles or less. And then in 4, why does an inequality make more sense than an equation in this case? Well, if you're dealing with a budget, like you have $20 to spend, you usually don't say, I want to spend exactly my entire $20. You'd be more likely to say, okay, I can't go over $20. I want to spend that or less. In 5, we're still looking at this cab fare formula, and so let's say that you expect to spend at least $30 but not more than $50. So we're going to write an inequality that matches these conditions. Well, in this case, that would then be a compound inequality because we're saying that we think it's going to be between $30 and $50. And at least $30 means that it would include $30 as a possibility. And don't spend more than $50 means you could spend up to $50. So $50 would also be included. So that's going to be $30 less than or equal to the cost of the cab ride, which is less than or equal to 50. And then we actually had a formula for the cost of that cab ride. So that'll be 30 less than or equal to 5.1 plus 2.6m less than or equal to 50. And then in number 6, we're going to solve that inequality. So first we'll subtract 5.1 from all 3 parts of that inequality. And that's going to give me 24.9 less than or equal to 2.6m less than or equal to 44.9. Now I need to divide all 3 parts by 2.6. So rounding each of those values off, I'm going to get about 9.6 less than or equal to m less than or equal to about 17.3. And then in 7, what information does that give us? Well, that tells us that to spend between $30 and $50, we can ride between 9.6 and 17.3 miles, including both of those values. Still looking at this cab ride formula, in question 8, suppose you have a maximum of $50 to spend, but you need to make a round trip. So which of these inequalities that are given best describes that situation? Well, they all say less than or equal, and that makes sense because we can't go over $50, so we want to be less than or equal. And then we need to figure out, what does the fact that it's a round trip do to this? Well, the one that makes the most sense would be C, and the reason for that is that you've got the cost here of the cab ride, 5.1 plus 2.6x, and then you've got 2 times that, so you're doubling the cost because it's a round trip. So C would be the one that makes the most sense. And then in 9, we're going to go ahead and solve that. And they've switched the variable from an m to an x, but that doesn't really matter. Either way, the first thing that we need to do is distribute the 2 on the left, because we can't really solve this with the parentheses in there. So distributing the 2, I get 10.2 plus 5.2x, and that's still less than or equal to 50. Now we need to get the x by itself. So we're going to subtract 10.2 from both sides. That's going to give me 5.2x less than or equal to 39.8. And then I need to divide both sides by 5.2. And that's going to give me x less than or equal to approximately 7.7. And what does that tell us? Well, that means that the location that we're going to, if we need to make a round trip, better not be more than 7.7 miles away. In lesson 3.1, we had another formula that we worked with that talked about the depreciation in value of a car, and that equation was V equals 15,000 minus 2,000 t, and in this case t was the number of years since the car was purchased. So this owner has decided that he'll hang on to the car until it's worth less than $2,000. So we're going to write an inequality to describe that. Well, that means that he's going to hold on to this until the value of the car is less than $2,000. Well, we have a formula for V for that value of the car, and that is 15,000 minus 2,000 t. So that's less than 2,000. Now we'll go ahead and solve that. So first thing I need to do is subtract 15,000 from both sides. And that's going to give me negative 2,000 t less than negative 13,000. Then, to get t by itself, I need to divide both sides by negative 2,000. But be very careful here, because when you divide both sides by a negative number, that's going to change the direction of the inequality. So this is now a greater than. And so that's going to give me t greater than 6.5. So what does that tell me? Well, that tells me that if the owner wants to keep this car until it's worth less than $2,000, then he'll need to keep the car for more than 6.5 years.